Okay. So looking at today, we're going to be working from 17 through 24. Let me zoom into number 17. Nice thing on here on triangles is that there's one side that has only numbers, and there's another side that is there's a question mark. We're going to call that the side that we're missing. Have a question here. It says, will you do this for the whole semester for Zoom? Yes. I was saying that you have from 7:30 to 9, I'm available via email, but I can log in. And if you guys, the lecture, I mentioned the time for the lecture, and I'm also available afterwards. Okay. So let's take a look. Just looking at the side that it has numbers. So my focus is right here. I noticed that the entire side is 16 and part of it is 12. Like, I'm just looking at the part that is all numerical. The entire side is 16 and part of it is 12. I'm going to say the other little part here is 4. Right. When I'm looking for a small side, I subtract those two values, 16 minus 12. So it gives me the other side is 4. Okay. So what I'm going to be looking at now, I learned back in algebra. Back in algebra, we learned that when we don't know the value of something, we replace it with the letter. It's usually x, right? In algebra, we should say solve for x. So when we don't know the value of something, we replace it with the letter. So this question mark, let me replace it with an x. What I'm going to do is from the side that has the x, I'm going to choose those two numbers. So I'm going to choose x and 21, and I'm going to make a fraction out of that. I'm going to say x over 21 equals. Yesterday, we talked about proportions, cross multiplying. So x over 21, it doesn't matter if you put the x on top or you put the 21 on top. The order does not matter. The next fraction will matter though. I'm going to write a fraction. The x is the small side. So x is going to go with this 4. So x goes with 4. 21 is this bigger side. 21 goes with 12. I'm not going to use the 16 when I make the fraction because 16 is the entire side, right? I could make it a fraction, but it will have to go with x plus 21. A little more complicated, so I'll just leave it at that. I mentioned yesterday, we could simplify. If we could simplify our fractions, I have 4 over 12. We could simplify that as a 1 over 3. I also mentioned we can simplify sideways. The 21 with the 12, we could divide each by 3. We could simplify that as well, or we can just cross multiply whenever. Because I have the use of a calculator, I'm just going to cross multiply. So I'm just going to go here. X times 12. That gives me 12x equals 4 times 21. That gives me 84. So I have the 12x equals 84. Again, we could have simplified to deal with smaller numbers, but you can cross multiply whenever. To get the x by itself, I have 12x, technically 12 times x. The opposite of times is divide. Let me divide both sides by 12. So I cross out those 12s. Now I'm going to go x equals 84 divided by 12. Use a calculator if you need to. 84 divided by 12 is 7. So x equals 7. As I mentioned yesterday for the homework, you don't have to type in x equals. I'm finding the missing side. As a matter of fact, it was never x to begin with. I called it x because I didn't know it. So I called it x, but you don't have to type in x equals. You just have to type in the number. So x equals 7, just type in 7. On the quiz, it lets you not type in x equals. If you type in x equals, it tells you it's numerically. The answer is supposed to be a number. Just to remind you, you don't have to type in x equals. The homework would let you type in x equals, but then it will mark it wrong. So don't type in x equals. All right, let's take a look at number 18. Again, I'm just going to start by focusing where the numbers are. I noticed that small number of, well, part of it is 2. Another part here is 1. So I'm going to say the entire side is 3, right? Because I added 2 and 1. I might use the 3. I might not use it. I'm just going to have it just in case. And then I see the side where there's a question mark because I'm supposed to solve for that. But again, back in algebra, I learned that when I don't know the value of something, I replace it with the letter. It's usually X. I have a question here. It says, yesterday, the computer graded my test wrong. You double checked and fixed the quiz or assessment. The computer graded wrong. Yeah, I do check the grades. If it grades it wrong, the computer grades it wrong, I do fix it. Okay, so now here again, the question mark, I replace it with X. Then I'm focusing on the side where X is, and there's two values, X and 2. And I'm gonna make a fraction out of that. So I'm gonna write X over 2 equals. Now, X is this bigger side, which goes with 2. X is corresponding to 2. And then this little 2 goes with this little 1. So 2 goes with 1. I'm not going to use the 3. But like I said earlier, I'm going to have it just in case I need it. Right? 3 is the entire side. 3 will go with X plus 2. The entire side. But I'm not going to use that. All right, so let me cross multiply it. I'm ready to cross multiply it. I have a question here is how come you subtracted on the first one, but on this one you added? Let me finish this question and then I'll come back to that question. So, all right, so here, I'm just gonna cross multiply it. 1 times X, well, just X. 2 times 2, that gives me 4. So I have that X is equal to 4. Again, you don't have to type in X equals, you just have to type in 4. Now, question was, how come on 17, I subtracted my values, right? In order for me to come out with the 4, how come I subtracted 16 and 12? But here I added 1 and 2 to come out with the 3. The reason why I subtract on question 17, when you're finding a smaller side, not the big side, but one of the two smaller sides, you subtract the values. All right, notice that focusing on the side that is all numerical, just numbers, there's two small sides and a bigger side. When I'm finding one of the two small sides, I subtract my values. When I'm finding the big side, which is number 18, I add the values. All right, looking at question number 19. I'm finding one of the small sides. I see the entire side is 6, and one of the small pieces is 2. So I'm going to say the other part here must be 4, right? I subtracted my two values, 6 and 2. Keep in mind, measurements are always positive. So I went 6 minus 2 to get a positive value. I didn't go 2 minus 6 because that will give me a negative value. Right? Keep in mind, measurements are always positive. Okay, now I'm going to see where the question mark is, what I'm solving for. Again, back in algebra, I learned if you don't know the value of something, replace it with the letter. So that question mark, I'm going to call it X. And on the side where X is, I see two numbers. There's an X and there's a 12. So I'm going to make a fraction, X over 12 equals. Now, X is this side. It's corresponding. You guys can tell it goes with 4. So X is corresponding to 4. Now here, 12. 12 is the entire thing, the entire side. So 12 is going to go with 6. Because it's the entire side. I'm not going to quite use 2 when I make my fractions. I see a 2. I'm not quite going to use 2 because I don't know what 2 goes with. There's a blank there. Okay. Now I'm just going to cross multiply. Again, we can simplify. We can simplify whenever. But I'm just going to cross multiply. Let me go this way. 6 times X gives me 6X. 12 times 4 gives me 48. To get the x by itself, let me divide both sides by 6. And I know 48 divided by 6 is 8. So x equals 8. And again, I'm just going to type in 8. Let me do one more of these. Again, later I'm going to zoom out so you guys will be able to see it. Let's see where it is all numerical. I'm just want to see the one side that is all numerical. Part of it is 12. Part of it is 20. I see 12 and 20 are two small pieces. So I'm going to add 12 plus 20. I know that's 32. So I'm going to say the entire side is 32. Again, I might use the 32. I might not. I'm going to have it just in case. So the question mark on the other side, the question mark, I'm going to replace it with an X. On the side that is all numerical, I'm going to use the side where the X is, I see two values, X and 56. I'm going to make a fraction, X over 56. Again, it doesn't matter if the X goes on top or the X goes at the bottom. Just using the two values, we make a fraction. It really doesn't matter the order. The second fraction does matter. Now, X, I can tell this small piece on the very top, X is going to go with 12. So X is corresponding to 12. And 56, I notice 56 is the entire side, the big side. So I look on the other side and I start thinking, does it go with 20? Does it go with 32? Is the big side. So 56 will go with 32. I could cross multiplied. Again, we could multiply, but in this case, I am actually going to simplify. I don't want to deal with such big numbers. I could simplify top and bottom, 12 with 32, right? I could divide them by probably by 4, or I can simplify sideways. When I say sideways, I'm looking at the 56 with the 32. I can simplify sideways, and that's exactly what I'm going to do. Let me divide each by 8. Right, 56 and 32, let me divide each by 8. So 56 becomes 7, and 32 becomes 4. I could probably simplify even more, the 12 over 4. If you do that, do leave it as a fraction, right? 3 over 1. But as I mentioned yesterday, we can cross multiply whenever. I'm not going to quite simplify all the way. I'm just going to cross multiply. So I'm going to go here, x times 4 or 4 times x, that gives me 4x. 7 times 12, that gives me 84. To get the x by itself, let me divide both sides by 4. X equals 21. Make sure, because we're dealing with proportions, we're dealing with fractions, make sure you simplify all the way first, like the fraction 12 over 4. I know 12 divided by 4 is 3. Do leave that as a fraction, 3 over 1, when you're doing the work, because we need it as a fraction because we're going to cross multiply. All right, so I believe those first 4 are not that difficult. Now, the next 4, the same idea. It's just that here on question 17 through 20, I had a triangle. You notice I had a triangle and 2 parallel sides inside of it. Now, 21, it doesn't quite complete the triangle, but I still have parallel sides. And we're going to treat it the same way we did the first 4 questions. I see the side that it's all numerical. And I see there's a 15 and there's a 27. So I'm looking at the side that is all numerical, right? When I say numerical, it means just numbers. 15 is a small piece. 27 is the big part. So I'm going to say this other piece is 12. I subtracted my 2 numbers. 27 minus 15 gave me 12. All right. Now looking at the side that has the question mark, let me replace that with x. And I notice that I have x and 25. So I'm going to make a fraction. X over 25 equals, I see that x goes with 12. And 25 is corresponding to 15. We could cross multiply. We can simplify. Let me simplify. We could simplify the fraction 12 over 15, or we could simplify sideways the 25 with the 15. Let me go 25 and 15. I can divide each by 5, so that becomes 5 and 3. I'm going to cross multiply already. The idea with proportion is cross multiply whenever you feel comfortable. You don't have to simplify all the way. The idea is to cross multiply, not to simplify. So let me cross multiply here. 3 times x gives me 3x equals 12 times 5. Well, that's 60. So I have that 3 times x equals 60. To get the x by itself, let me divide both sides by 3. X equals 20. And again, you don't have to type in x equals, just 20. Looking at number 22, the side that is all numerical, I see 9 is the entire side, and I know 3 is part of that. So I'm going to say this other part here is 6. I subtracted. 9 minus 3 gave me a 6. Now, on the side where the question mark is, the side that I'm solving for, I don't know what the question mark is. I'm solving for that. To begin with, let me replace it. Let me call it x. Again, when I don't know the value of something, I always call it x. So I see on that side, I see x in the 4. So I'm going to make a fraction. X over 4 equals. X is corresponding to 6. 4 is corresponding to 3. I'm not quite going to use 9 when I make my fraction because I'm not using the entire side. A ratio equation could work also? Yes, definitely. A question and it says, would that work? Yeah, a ratio equation can work as well. Now here, let me take a look. I'm going to solve. I'm not just going to cross multiply. The numbers are kind of small, so I don't have to simplify much. I'm just going to go x times 3 or 3x. 6 times 4, that's 24. So I have the 3x is equal to 24. To get the x by itself, let me divide by 3. X is equal to 8. There's actually a few ways how this can be done. And this is the beauty of what we call common core. Right? Common core, unfortunately, many people hate the phrase. Oh, common core. But the thing is that teachers don't quite understand what common core is. Common core is, I'm going to teach you a few ways. But if you know another way or you're comfortable with a way, you don't have to learn all the possible ways. But as long as you're comfortable with one and you're good at it, go for it. Notice on my homework, I only grade the answer. So how do you got it? It doesn't quite matter. Now looking at number 23, I'm looking at the side that is only numerical. Part of it is 4, part of it is 3. So I'm going to say the entire side here is 7. Again, I added when I'm finding my twos, when I'm finding one of the big sides and I have 2 small sides, I just add the 2 small sides. Now on the other side, the question mark, I replace it with x, and I have x and 14. I can write x over 14, but just to emphasize, because earlier I said it doesn't matter if the x goes on top or the bottom, just to emphasize, let me not put the x on top. I'm going to write 14 over x. If you wrote the x over 14 already, leave that. Leave that alone. Like, leave it as x over 14. I'm going to write 14 over x, just to emphasize that x doesn't have to go on top. Now here, my second fraction matters. 14. 14 is the big side. So 14 is going to go with 7. X is this small side. So x is going to go with 3. So if you wrote x over 14 equals 3 over 7. Now you guys can probably see why it doesn't matter if x goes on top. Now when I cross multiply, I always start with the one side that has x. Here I go 7 times x. Well, that's 7x. 14 times 3, that's 42. Let me divide both sides by 7. So x equals 6. And I'm just going to type in the number 6. And lastly, let's take a look at number 24. I always start with the one side that is only numbers. One small side is 8, one small side is 10. So I'm going to say the entire side. The big side is 18. I might need the 18. I might not need the 18. I'm just going to have it just in case. Now, on the other side, the question mark, let me replace that with an X. And I have an X and a 12. And I'm just going to write X over 12. Or 12 over X. It doesn't matter. Now, X is corresponding with 10. So X goes with 10. 12 is corresponding to 8. And I can just cross multiply, or I can simplify first. I'm going to cross multiply. Numbers are not that big. Especially if you guys have calculators with you. Just cross multiply if you're comfortable with. Now here, 8 times x, that gives me 8x. 12 times 10, that gives me 120. So I have that 8x equals 120. To get the x by itself, let me divide by 8. Right? Use a calculator if you need to. And that gives me 120 divided by 8 gives me 15. So when I type in my answer, I'm going to type in 15. Let me zoom out. Save it on your notes. Let me see. Save this on your notes.